Hello, math friends. We are going to venture into absolute value graphs and transformations. Transformations are just changes that you make to a graph. This does not have a ton of room, so I'm just going to cram stuff in here. The parent function graph is just going to be y equals absolute value x, which means there's nothing. Like, this is the basic graph. What I don't love is I don't have any space here to create one. So what I'm going to do is I'm going to make a little chart over here just to plot some points. I'm still sick, I'm sorry. So let's pick some negatives and some positives. You'll recall maybe that absolute value measures distance from zero. So like this with a -2 would be saying how far is -2 from zero, and the answer would be 2. How far is -1 from zero, and so on. And so it effectively turns everything positive. So if I plotted these points, my first one's -2, +2. My second one's -1, +1, 0, 0, 1, 1, 2, 2. So I end up with, uh-oh, I think my pencil died. That is not what we need right now. I end up with a V shape. Now all the lines I drew came in. And then here. So I'm going to erase that because that's so messy now that I made it blobby. Let me try again. Okay. Now you can kind of see what I was about to say is that this has a vertex right here at the origin, 0, 0. And then the slope of the right is up 1, over 1, up 1, over 1, up 1, over 1. That's something that I like to remember because that's going to be one of the numbers that we see in our equation. And then to get to the other side, you go up 1, back 1, up 1, back 1. That's kind of how I think about it. They're sort of mirror images of each other. So the beauty of the domain on these is that since they're always that V shape and they go off forever and ever left and right, the domain is always all reals, which is going to be from -infinity up to +infinity. Remember, for domain, it's x. So that's going to be always the case for every absolute value graph. So actually not that interesting. However, range is not always the same. Remember, range is how low it goes, like the lowest y up to the highest y. So in my case, the lowest it goes is right here at 0. It actually touches 0, y in the middle, and then it goes up forever. So it's going to go to infinity, and you can't get to infinity, so it is not included. So transformations are going to be the changes that occur, and the transformations are going to put numbers around that parent graph that we had. The number out in front, A, let's talk about that first. First of all, if you have a positive A, it's going to open up, and a negative A will open down. A also, in my, like the way I think about it, is the slope of the right side. And then you do the mirror image for the left. Also, if you have a bigger number, like a number greater than 1, it's going to have a higher slope, so it's going to be steeper. So that's going to make that V kind of narrow, tall, and skinny. If you have an A value less than 1, and I'm not looking at the positive or the negative, I'm just looking at the number itself, that's going to go, like say I had a half. 1/2 is less than 1. I'd be going up 1, over 2, up 1, over 2. And so it's a slower rise, and that's going to make that a little wider than the parent graph. So A has a lot of control over the shape, the steepness, whether it's opening up or down. And then this is an H and a K in here. What you want to think about is like what we've talked about in the past. Things that are in here with the X, move it left and right, but they always do the opposite of what you expect. So a negative H in there is actually going to move it to the right. And a positive H in there is actually going to move the whole thing to the left. The K on the outside is on the outside of the bars, and it's going to do what you think. It's going to move it up if it's positive and down if it's negative. So moving it up, down, left, right is going to move all the points, and it's going to move that vertex. So probably the easiest point to find is the vertex. It's just an eyeball activity, similar to what we did with parabolas. You're going to be looking at the opposite of the H. So the opposite of whatever you see for H and then the K as it appears. That's going to give you that kind of starting point, the vertex, where the two little arrows meet, creating that V shape. So let's go ahead and think about how would I do this, writing an equation. Okay, I think this is kind of a tricky place to start, but let's go for it. First thing I'm going to think about is, where is my vertex? It's right here. What are the coordinates at that spot? 2, 1. So keep in mind, that means I went to the right 2. I went up 1. And then what I need is the slope of the right side. So I go up 1, over 2, up 1, over 2, it appears. Well, that got messy. And so if I'm on here, I'm going up 1 square, over 2, up 1, over 2. And so the slope of that line, which is going to turn out to be the A value in my equation, is up 1 over 2. So these changes or transformations that I'm noticing are going to be the numbers in my equation. They got me started with y equals. The A value out in front, like we talked about, it should be the slope of the right side. So for me, that's 1/2. Now, I went to the right 2, which actually means I'm going to go -2. The other thing to keep in mind is up here, the opposite, the number in the X spot of the vertex is opposite of what you have inside the bars. So I have a +2 in my vertex, a -2 in the bars. And then it went up 1, we said. Okay, well, the K at the end, according to our notes, tells us if it's going up or down, and it does exactly what you think because it's not inside the bars. So these are going to be the changes I make to have my absolute value graph be less steep, up 1 over 2, up 1 over 2, move over 2 to the right and 1 up. That's going to be that new location for the V and the vertex. All right, so let's practice a few things. This is walking us through the step. Tell whether it opens up or down. So think about what that's asking you. Up is going to mean that you have a positive A. Down is going to mean you have a negative A. Is it wider, narrower, or the same? Well, that would mean here that you don't even see an A value. It's a 1 out front. Narrower is going to mean it's steeper, so it's got a greater slope than 1. And then wider means it's less steep, so it's going to have a slope less than 1. Identify the vertex. That's going to be where you take the opposite of the number inside the bars as the X, and then the number after the bars as the K. Range is going to be tricky. You're going to probably do that after you graph it, because you have to visualize what's the lowest it goes and what's the highest it goes. So personally, I would flip-flop these because I'm going to graph it first and then figure out my range. It's easier to just visualize. So in part A, tell whether it opens up or down. Well, this one doesn't have a number out in front of it. And so what that means is that your A value is simply just a 1 in there. But it is positive, so it's going to open up. Part B said, is it wider, narrower, or the same? Well, since it just has like a 1 in front, it's just going to be the same as the parent graph, because the parent graph doesn't have anything in front of the absolute value bars either. C wants us to find the vertex. Don't work too hard. Look at these two. Take the opposite of what's inside and the outside as it appears. So my vertex is going to be 1 to the right, up 1, 2, 3. And then my V is going to go from there. So I'm going to, before I do my range, I'm going to go ahead and graph it. Since my A was 1, that's the slope of the right side. From this vertex, I go up 1, over 1, up 1, over 1, and I draw in that right side. Then I can go up 1, back 1, up 1, back 1 to get the left side because they're mirror images. All right, so now I'm going to do my range. The range is the lowest it goes, and the lowest it goes is right here, and that is a Y value of 3, which it actually touches, and then it goes up forever. Okay, this one looks a little weird because Y is not alone, so I'm going to take this 3 over to the other side. So I'm graphing Y equals the absolute value of X and then a -3 at the end. First one's asking if it will open up or down. Well, if you look in front of the bars, you don't have anything, so that's like having a +1. So it will open up, but it will be the same steepness as the parent graph because there's no different slope number out front. In C, I'm looking for the vertex. I'm supposed to take the opposite of the number that's added or subtracted to X on the inside, but there isn't one, so I'm going 0. And then the number on the outside as is. So 0 and then down 1, 2, 3 puts me right here for a vertex. My A value is 1, so up 1 over 1, up 1 over 1, up 1 over 1 gives me the right side. And then if I go up 1, back 1, up 1, back 1, I end up with my left side. Then it asks me for the range. So again, the range is the lowest it ever goes, which is right here. That's at -3. It actually touches that. I'm talking about range, so Y, and then it goes up forever from there. Keeping in mind those kind of little alligator mouths are always opening to the right when you're doing range. And the reason that they're not asking us for domain every time is that it's always all rails, always from negative to positive infinity. All right, let's work our way through these last two. This one, the only transformation or change it has is a number out in front, and that is my A value. Since it's positive, it's still going to open up, but because it's greater than 1, it's going to be steeper. It's going to go up 3 over 1, up 3 over 1, and since it's going to be steeper, then the absolute value graph, the V shape, will be more narrow than the typical one. Now I'm finding my vertex. Now this might seem confusing, but the A does not factor into the vertex. I use the number in here and the number in here, and there isn't one for either. So then that's 0 inside and a 0 outside. So the origin is actually my vertex still. It hasn't moved left or right or up or down. And now I just use my A value, up 1, 2, 3 over 1, up 1, 2, 3 over 1. So it is indeed tall and skinny because this is the right side. And if I go up 1, 2, 3, back 1, 1, 2, 3, back 1-ish, I end up with a mirror image. And obviously it's taller and skinnier than the parent graph that we did. So my range is how low it goes, and it goes down to here. And that's a Y value of 0, which it actually touches. And then it goes up forever from there. This is a doozy. This is like the grand finale where everything's happening at once. What is this doing? Well, it's at the end, so it's going to move it up 1. This is inside, so it does the opposite of what I expect. So even though it's a minus, it's actually going to move to the right 3. This is going to flip it over, and because it's flipped over, it's going to open downward. And then this, too, is going to make it a little more narrow than before. So the easiest thing to start with, honestly, is the vertex. So I'm just going to skip to that. And I'm going to look at these two numbers, and I'm going to say I need to use the opposite of what's in the bars and the number on the outside as it appears. So I go 1, 2, 3, up 1, which is what I expected. Because when I looked at this, I expected to go to right 3, up 1. So that's my vertex. Will it open up or down? Well, that depends on A. It's negative. A is -2. So it's actually going to open down. That's the first one we've seen. Will it be narrow, wide, or the same? I don't care about the negative. I only care about the number. And since 2 is greater than 1, the steepness will be greater than 1. And so this one's going to be narrow as well. And then my range. Let's go ahead and graph it. So I can still, once I have the vertex, that's like my starting point, and then I just use the A value, and my A value is -2. That's my slope to the right side. So from my vertex, down 2 over 1, down 2 over 1, down 2 over 1. I just use a lot of dots because I'm not that great at making the line straight, even though notability is the greatest thing ever. Down 2, back 1, down 2, back 1, and that'll give me the matching left side. Please straighten that out. Thanks, guys. So don't make it overly complicated. Just kind of find your vertex, start there, use the A value as your slope. Now this last one for the range, you have to slow down a little bit because it actually goes down forever. So the lowest it goes is -infinity, which you can never get to. And then the highest it goes is right here, and that is at a Y value of 1. So that's the first one we've seen kind of flip-flopped, but that's because it's the first one we did that is literally flipped over. Hopefully that helps you out. Don't overthink this because this part's pretty straightforward. Just look at your notes until you don't have to look at them anymore. Thanks, guys.